Hello everyone, welcome to Physics online classes for class 11 students. Let us continue chapter 4 Motion in a Plane. Today we are going to study about properties of vector product. We already know that vector product is also called as cross product, and in the previous class we studied what is vector product and its equation, and also we studied how to find the direction using two rules, and those two rules are right hand thumb rule and screw rule. And the equation is vector A cross vector B equal to magnitude of vector A into magnitude of vector B into sine theta into n cap, and that is a unit vector which represents direction. So let us continue the cross product or vector product in today's session. We can study the properties of cross product. What is the first property? Cross product is non-commutative. It is not obeying commutative property. It is non-commutative because vector A cross B is not equal to vector B cross A. Because you can observe this example here, we considered vector A cross B, vector B cross A. Their directions are exactly opposite. So we can write vector A cross B is equal to minus of vector B cross A because their directions are exactly opposite. Right? Then second point, cross product is a distributive property. Means it obeys the distributive property. What is that property? Vector A cross B plus C is equal to vector A cross B plus vector A cross C. So this obeys distributive law or distributive property. And you can take three vectors, vector A, vector B, vector C. Right? You can observe here. I am going to consider vector A value as 2i cap plus 3j cap plus 4k cap. And vector B value I am going to consider 3i cap minus j cap plus 5k cap. Similarly, vector C equal to 5i cap minus 9j cap plus 6k cap. Right? We can use all these values, substitute here. Vector A cross B plus C. First you go with vector B plus vector C. Then let us multiply with vector A. Then similarly for RHS side also you can go with A cross B and then A cross C. Then you add it. You will get the same answer. There is no change in LHS and RHS value. But here we have to use some orthogonal unit vectors. When you understand orthogonal unit vector for cross product, then it is easy to solve this equation. So in dot product also we solve the same property, it obeys there. Likewise here also we have to solve, but before that you have to understand orthogonal unit vectors, right? We can go for the next property. The magnitude of cross product of two perpendicular vectors is maximum. Only we are talking about magnitude when two vectors are perpendicular. Let us take this is vector A and this is vector B. If they are perpendicular, angle between them is 90 degree. What is the expression for cross product? Vector A cross vector B is equal to mod of vector A into mod of vector B into sine theta. We are going to talk only about magnitude. Don't write direction, that is n cap. Leave it. So AB sine theta, theta is 90 degree, sine 90 is 1, so we will get AB. So this is maximum. That indicates when two vectors are perpendicular, then a cross product of two vectors is maximum. Then if fourth property, the cross product of two parallel vectors is minimum, that is 0. When two vectors are parallel, angle between them is 0 degree. Substitute here. So we will get vector A cross vector B is equal to mod of vector A, mod of vector B into sine 0. Sine 0 is 0, 0 into anything will be 0. That gives minimum value. When two vectors are perpendicular, it is maximum. When two vectors are parallel, cross product is minimum. Then to understand fifth property, let us consider orthogonal unit vectors. Orthogonal unit vectors in dot product also we studied. Likewise, we can study for cross product. Orthogonal unit vectors. Orthogonal means all these three vectors are mutually perpendicular. So we can take x-axis, y-axis and this is z-axis. So for x-axis we can consider unit vector I cap, for y-axis we can consider j cap and here we can consider k cap. This is what? Orthogonal unit vectors. I cap, j cap and k cap are the unit vectors which are represented along x, y and z axis. Now I want to find the value of I cross I. I cap cross I cap. We know the formula. What is that formula? We know the formula, that is mod of I cap into mod of I cap into sine theta. Mod of I cap into mod of I cap into sine theta into n cap. Magnitude as well as directions. Yes. Mod of I cap into mod of I cap into sine theta. What is the value of theta here? Theta is equal to 0 degree because this is I cross I. I cap is along x-axis, another vector is also same. So angle between them is 0 degree because both are parallel. So sine 0 is what? 0. 0 into anything will be 0. So if there is no magnitude, then there is no value for direction. 0 into anything will be 0. Similarly, when it comes to j cross j. J cross j, same formula we can use here. Mod of j cap into mod of j cap into sine theta into n cap. J cross j means again both are parallel. Theta equal to 0 degree. 0 into sine 0 is 0. 0 into anything will be 0. Similarly, I can take k cross k. So we can use mod of k into sine theta into n cap. But here theta equal to 0 degree. So sine 0 is 0. 0 into anything will be 0. That gives I cross I, j cross j, k cross k is equal to 0. Right? Okay. Now we can study about I cross j value. Okay, let us find I cross j. Again we can use the formula here. Mod of I cap, mod of j cap, sine theta into n cap. Yes, mod of I cap, mod of j cap means their value magnitude is how much? 1 into sine of, what is the value of theta? Theta equal to how much? I cross j. Both are mutually perpendicular to each other. So angle between them is 90 degree. So we can write sine 90 n cap. So sine 90 is 1. 1 into anything will be 1. 1 into 1 into 1 into n cap, that gives direction. So 1 into 1 into 1 will be 1. So we will get the answer n cap. I cross j equal to what? N cap. That gives the direction. Yes. Again you can use the rule, screw rule or right hand thumb rule. Let us move your fingers from I to j vector. I to j. When you are moving I to j, so that thumb is outward. Outward direction means we will get k cap. Because for I and j, for these two axes, here, this is x axis, this is y and z axis. When you consider xy axis, z is perpendicular. When you consider y and z, x is perpendicular. When you consider z and x, y is perpendicular because all three axes are perpendicular, mutually perpendicular to each other. When you are moving right hand from I to j, thumb is outward. Outward means it is along z axis. So z axis means which vector we have to consider? K cap. So here vector I cross vector j or I cap cross j cap is equal to k cap. So why we have to write k cap here? Because that gives the direction and its direction is perpendicular to the two vectors. I cross j equal to what? K. Similarly, if I am going to find j cross k, we will get the answer. See here I am going to write I cross j is k, j cross k, that gives I. You can rotate here. I to j, that gives k. J to k, that gives I. K to I, that gives j. Means k cross I. K cap cross I cap, that gives j cap. These values you have to remember. Is it clear? I cross j gives k. J cross k gives I. K cross I gives j value. Then suppose if you want it's in a reverse order, I want the value of j cross I. What will be the answer? Whether you will get the same answer or different, you can observe here. I cross j is not equal to j cross I because it is a non-commutative property. J cross I is equal to, again I can use the same formula here, mod of j, mod of I, sin theta, n cap. Mod of j is 1, mod of I is 1 into sin 90 degree n cap. So that gives 1 into 1 into 1 into n cap. So we got the answer n cap. That gives direction, but where is the direction? So you have to again move right hand from j to I. When you are going to move your right fingers or right hand fingers from j to I, your thumb is inward. Inward means it is exactly opposite to z axis, means minus z axis. Inward. Here it is outward. When you are moving from j to I, it should be inward. So it is in the opposite direction. So we can write minus k cap. J cross I equal to minus k cap. Let us reverse the orders. See here, J cross I is equal to minus k cap. Then second one, J cross k, but we can write here k cross j, that gives minus I. Similarly, third one, I cross k, that gives minus j. I cross k equal to minus j. So these values you can remember. See here, I to j, when you are moving, you will get k. J to k, when you are moving, you will get I. When you are moving from k to I, you will get j. If you are moving in reverse order, you will get negative. I cross k gives minus j, k cross j gives minus I, j cross I gives minus k. So this is all about orthogonal unit vectors. You can observe this second box here. I cap cross j cap equal to k cap. So in the reverse order, j cross I, that gives minus k. Similarly here, j cross k equal to I, k cross j equal to minus I. Similarly, k cross I equal to j, I cross k equal to minus j. So this is all about fifth property, that is orthogonal unit vectors. Sixth property, unit vector perpendicular to the plane of vector A and vector B. How to write the expression for unit vector? N cap equal to vector A cross vector B. This is cross product divided by its magnitude. N cap equal to cross product divided by its magnitude. Then seventh property, cross product of two vectors in 3 dimensions. When it comes to 3 dimensions, we already studied in dot product. Same wise we can follow here also. This is vector A cross vector B. Vector A value is given as AXI cap plus AYJ cap plus AZK cap. Vector B value is given as BXI cap plus BYJ cap plus BZK cap. So we have to multiply vector A cross vector B. So first we can take AX into BX, I cross I. What is the value of I cross I? I cross I is equal to 0. So this term will be 0. Right? Then AY into BY, J cross J. 0 into anything will be 0. Leave it. AZ into BZ, K cross K. K cross K is again 0. 0 into anything will be 0. So this term will be completely 0. Leave it. Then AX when it is multiplied to BY. AX multiplied to BY. Remaining is what? I dot J. I cross J. I cross J means K value. In this way, you go on, substitute the value. Finally, we will get this answer. What is the expression? AYBZ minus AZBY I cap plus AZBX minus AXBZ J cap plus AXBY minus AYBX K cap. So let us take it as a homework. Try to solve this problem. You will get this answer. Or simply you can use determinants here. I cap, J cap and K cap. So here I cap is AX, BX, J cap means AY, BY and K cap values are AZ, BZ. So we can find using this value I cap into AY, BZ, cross multiply. You studied in mathematics, you can remember, minus BY, AZ. In this way also you can easily write the expression for 3 dimensionals. Then last property, the magnitude of cross product of two vectors is equal to area of parallelogram. This sentence is very important. Cross product of two vectors is equivalent to area of the parallelogram. Area of the parallelogram means what? Base into height. Having two vectors as its adjacent sides. See here, you can observe this diagram. Vector A and vector B, these are the two adjacent sides of a parallelogram. So vector A, this is also vector A and this is vector B. Because OP, QM are parallel, OQ, PM are parallel. So we consider two vectors as the adjacent sides of a parallelogram. Angle between these two vectors is theta. So here we know that cross product of two vectors is equal to area of the parallelogram. So now I am going to consider area of a parallelogram OPMQ. Observe the diagram. OPMQ, this is a parallelogram. Now let us find the area. Area of the parallelogram is given by base into height. So base is how much? Base means O to P. We can write OP into height. Height means we have to draw a line QN. This is dotted line, you can observe here. This dotted line gives a height here. So OP into QN. Base into height. So OP keep as it is QN. QN means here there is angle theta. Right? So theta is here. This will be opposite side. This is adjacent side and this is hypotenuse. So we want opposite side value. QN value we want. So we can take sin theta equal to opposite side divided by hypotenuse. Opposite side is QN divided by hypotenuse is OQ. Sin theta equal to QN by OQ. We want QN. So QN equal to OQ sin theta. So here I am going to write OQ sin theta. Now from the diagram OP is equal to vector A into OQ gives vector B into sin theta. So we can write A, B sin theta. So here the cross product of two vectors that gives area of parallelogram AB sin theta. This is the magnitude of cross product of two vector and it is equal to area of the parallelogram. So these are the 8 properties of cross product, or we can also call it as a vector product. You can observe some examples for cross product. Torque. The first example is a torque and it is denoted by the symbol tau. What is this? Tau. Torque is equal to cross product of position vector into force. Generally, you are going to study later about the term torque. Torque is given by F cross R. This is the expression for torque. F indicates force, R indicates displacement, or you can take it as a position vector. Both are same. Force into displacement. Force is a vector quantity. Displacement is a vector quantity. Result is also a vector quantity. So we have to use cross symbol. Or we can write it as tau equal to RF, or we can write FR sin theta. This is for cross product magnitude. Then second example, angular momentum, and it is denoted by capital L, and angular momentum is given by the expression the cross product of position vector into linear momentum. Position vector is R, linear momentum is P, both are vector, result is also vector quantity. So here we can write it as Rp sine theta, that gives magnitude. Is it clear? So when the result is also a vector quantity, so we can use a cross symbol and we are going to call them as cross product or vector product. So this is all about cross product, or which is also called as vector product, and this completes product of two vectors or multiplication of two vectors.